Welcome to the DIY Honda Garage channel. The Honda Accord models from 2008 to 2012 may encounter diagnostic trouble code DTC P0102, indicating a low voltage condition within the mass airflow MAF sensor circuit. The MAF sensor is a critical component that measures the amount of air entering the engine. Its precise measurement helps optimize the air-fuel mixture for efficient combustion and engine performance. This code implies that the sensor is not sending a sufficient voltage signal to the engine control module, ECM, therefore affecting the vehicle's overall functionality. Issues can arise from faulty wiring, bad connections, or the sensor itself. Before proceeding with repairs, it's crucial to record any freeze frame data and run an onboard snapshot for initial diagnostics. The mass airflow MAF sensor is located between the air filter and the throttle body of the vehicle. Its primary function is to measure the volume of air entering the engine to maintain an optimal air-fuel mixture, which enhances combustion efficiency. A low voltage reading from the sensor indicates that it may not be functioning correctly, leading to issues such as poor engine performance, increased emissions, and potentially stalling. In addition to the MAF sensor, the intake air temperature IAT sensor may also play a role in this circuit, as they often share connections. Worn wiring, poor connections, or a malfunctioning sensor can cause low voltage outputs. Therefore, understanding these components and their locations is essential for effective troubleshooting. Several potential causes can lead to DTC P0102. A faulty MAF sensor itself is a primary suspect. If the sensor is damaged or malfunctioning, it will send incorrect signals to the ECM. Another cause could be an open circuit in the wiring between critical components, hindering the electrical signal that the ECM requires for operation. Poor connections at the MAF or IAT sensor, or even at the engine control module, ECM, can lead to inconsistent readings, triggering this DTC. Diagnosing these possible issues requires careful inspection and testing of the surrounding circuitry. Proper understanding of these causes can streamline the troubleshooting process. When experiencing issues related to DTC P0102, a driver may notice specific symptoms that affect vehicle performance. A rough idle can occur due to an incorrect air-fuel mixture caused by the malfunctioning MAF sensor. In addition, core acceleration might be observed as the engine struggles to perform due to incorrect air readings. The check engine light, CEL, is likely illuminated, signifying a need for diagnostic attention. Other symptoms may include reduced fuel efficiency and unexpected stalling of the engine. Recognizing these symptoms early can help address the issues before they exacerbate and lead to more extensive repairs. The first step in troubleshooting DTC P0102 is to turn the ignition switch to the on position, labeled II, and wait for 2 seconds. This step is crucial as it initializes the vehicle's onboard systems, preparing the vehicle for diagnostics. Following this, check the reading of the MAF sensor using the Honda Diagnostic System HDS data list. If the reading indicates approximately 0 grams per second, GS, or shows a voltage of 0.1 volts or less, this confirms a potential fault with the MAF sensor or its circuit. If a normal reading is observed, it suggests a transient or intermittent failure, and the system may be operating effectively at that moment. At this juncture, it is also wise to inspect for poor connections or loose terminals at both the MAF IAT sensors and the ECM. After completing the first step and recording the MAF sensor data, turn the ignition switch to the lock position, indicated by 0, to power down the vehicle systems safely. Next, disconnect the 5P connector associated with the MAF and IAT sensors. This will isolate the sensors for further testing. Once the connector is removed, turn the ignition back to the on position, ensuring that the vehicle systems are activated once again without starting the engine. This step is critical because it allows us to proceed with voltage measurements across the terminals without interference from the connected sensors. Properly following these steps is vital for accurate diagnostics. Next, measure the voltage across terminal number 3 of the MAF IAT sensor 5P connector and body ground. This check is an important diagnostic step to verify that the sensor is receiving adequate battery voltage. If the measurement reads as battery voltage, this indicates the wiring is intact and power is reaching the sensor. However, if there is no battery voltage present at this point, it suggests there might be an open circuit in the wiring between the PGM-FI main relay 1 and the MAF IAT sensor. Confirming that proper voltage is present at this terminal is essential before continuing with further testing of sensor function. After confirming battery voltage, the next step is to turn the ignition switch back to the lock position for safety. Following this, measure the resistance between terminal number 1 of the MAF IAT sensor 5P connector and body ground. This measurement helps determine the integrity of the MAF sensor circuit. A resistance value between 190 to 210 kiloohms is indicative of a properly functioning sensor. If the resistance falls outside this range, this points to possible sensor issues or shorts in the circuit. As resistance measurements play a crucial role in diagnosing electrical circuits, precise testing will help ascertain the problem with the MAF sensor. The next step involves jumping the SCS line using the Honda Diagnostic System HDS. The SCS, or Service Check Signal, acts as a means to reset the monitoring of the system. Jumping this line prepares the vehicle for further diagnostics by allowing you to clear past error codes and recheck the system effectively. This procedure can help eliminate any lingering issues caused by previous sensor errors or faults. By utilizing the HDS, you enable access to more advanced diagnostics features that can pinpoint the root cause of electrical issues affecting the MAF sensor circuit. This step ensures that the system is clear for accurate testing moving forward. The final step in our outlined troubleshooting process involves disconnecting the connector B49P from the ECM or Powertrain Control Module PCM. The ECM-PCM is vital for the vehicle's operation as it manages engine performance and emissions control. By disconnecting this connector, it allows for inspection and testing of the ECM or its connections to ensure they are functioning correctly. This step checks for any potential faults, such as corrosion or loose wiring, which might affect the communication between the ECM and the sensors. This approach ensures that all possible sources of the DTC P0102 are assessed effectively. After completing all necessary repairs related to DTC P0102, it is important to verify that all repairs made were effective. Begin by clearing the DTCs using the HDS to reset the system. After this, conduct a test drive to monitor the vehicle's performance and check for any return of the DTC. During the drive, observe for smooth acceleration, steady idle, and ensure that the check engine light remains off. Successful verification of repairs not only signifies that the DTC has been resolved, but also ensures the overall functionality of the vehicle. This step is crucial for confirming that the root cause has been addressed effectively. To prevent future occurrences of DTC P0102, regular maintenance and inspections of the MAF sensor and its electrical connections are essential. Taking proactive steps such as cleaning the MAF sensor can prevent buildup that might lead to erroneous readings. Checking connections for looseness or corrosion must be part of periodic vehicle inspections to ensure reliable sensor performance. Monitoring air filters for clogging or dirt buildup can also help maintain optimal airflow, which is crucial for both MAF function and overall engine performance. Such preventive actions extend the lifespan of the components and enhance vehicle efficiency. In conclusion, diagnosing and addressing DTC P0102 requires a clear understanding of the MAF sensor's function within the vehicle's air intake system. Following a systematic approach to troubleshooting, including voltage and resistance testing of sensor circuits, ensures thorough diagnostics. Effective repair should be verified by clearing DTCs and conducting test drives to confirm proper vehicle operation. Implementing regular maintenance practices will significantly reduce the chances of future faults in the MAF sensor systems. Ultimately, a proactive approach will help maintain your Honda Accord's optimal performance while minimizing unexpected repairs. Please like and subscribe to the channel. See you next time.